This month, AI crossed lines nobody expected. China deployed its first humanoid traffic cop, directing real cars, controlling crowds, and standing in the chaos of live intersections like a seasoned human officer. Xpeng stunned the world with a female robot whose runway-perfect walk disturbed even robotics experts. Tesla pushed the limits again with Optimus Gen 3, now fully autonomous inside its factories. Russia attempted to show off a human-like robot, but it collapsed the moment it started walking. And a new wave of ultra-realistic humanoids is making people question reality itself. Let's break down everything that went too far, starting with China's robot cop. China just unleashed a new humanoid robot, not in a lab, but on the streets, as an actual traffic cop. Yeah, you heard that right. This isn't some demo clip at the Shanghai China International Import Expo. The Fourier Intelligence GR2 robot was deployed as a working officer at busy intersections, waving cars to stop, signaling pedestrians to cross, and managing the chaos of city traffic in the middle of everything. Under the shell, the GR2 uses AI-driven computer vision and path planning to interpret traffic density in real time. It tracks flows of vehicles, reacts when something suddenly blocks the road, and updates its signals on the fly. If a crowd suddenly surges onto the crosswalk or a car tries to jump the light, the robot adjusts, just like a trained officer would. On top of that, the battery isn't just a weak demo pack. GR2 can operate for up to 2 hours on a single charge before a quick battery swap, which means it can work in shifts, just like a human team rotating positions. But what makes this deployment so important isn't just the cool visuals. It's the category of job it's doing. Fourier is proving that humanoid robots can handle complex, unstructured environments in public spaces. We're not talking about stacking boxes in a warehouse or tightening the same screw 10,000 times a day. We're talking about dynamic public service work, surrounded by humans who don't care they're part of a robotics experiment. Even more interesting, GR2 is built for customization. It supports developer tools like ROS and NVIDIA Isaac, which means cities could adapt the same platform for different roles. Today it's a traffic cop. Tomorrow it could be a crowd control assistant at festivals, a guide at train stations, or an emergency responder that rushes ahead to assess accidents before human teams arrive. The gap between robot in simulation and robot in your daily commute just got a lot smaller. And China chose traffic control, one of the most human, visible, and high-stakes jobs in a city, as the test case. If a robot can stand in the middle of an intersection and keep humans from crashing into each other, what else can it do? What do you think about this? Would you trust a humanoid robot directing traffic in your city? Let me know in the comments. I'm really curious where you stand on this. Now, while GR2 is taking over the streets, China has another robotic surprise coming from the military side. The team behind the robotic wolf that marched in China's Victory Day military parade, 58 Intelligence Technology, just made its next big move. They've unveiled a new quadraped robot called Sky Wolf. But here's the twist. This time, the main target isn't the military. It's business and industry. Skywolf takes the same core strengths that made the original parade robot so impressive: high mobility, strong terrain handling, and AI-based autonomy, and points them at real-world jobs. Think search and rescue in disaster zones, security patrols around large facilities, logistics in tough terrain, and inspection in hazardous areas where humans shouldn't be walking around. And that move is already paying off, because they've secured major funding to scale Sky Wolf into a real product, not just a parade moment. They've raised 500 million Chinese yuan, around $69.4 million USD. It gives 58 Intelligence the fuel to scale manufacturing, improve hardware, and upgrade its AI stack so Sky Wolf can compete with global players like Unitree, Ghost Robotics, and Boston Dynamics. And the message is loud. China isn't just building robots for parades and propaganda. It's commercializing them. What's your take on Skywolf stepping into real-world jobs? Cool upgrade, or a little too close to sci-fi for comfort? Drop your thoughts below. We've seen robots on the streets. We've seen a robot wolf stepping out of the military world. Now let's look at something that honestly feels like a shot straight from a sci-fi movie: a humanoid robot assembly line. China has been quietly entering a new era of robotics. Full-scale, mass production of humanoid workers. UB Tech just rolled out its first wave of Walker S2 robots, and the visuals are insane. Rows of tall humanoids lined up in factories, white shells, smooth joints, all waiting to be deployed to real industrial sites. This isn't some limited edition prototype run. This is mass manufacturing that kicked in around mid-November 2025. Walker S2 is built like a serious industrial teammate. It comes with an autonomous battery swapping system. The robot can dock itself, eject a drained battery, slot in a fresh one, and go straight back to work without a human lifting a finger. That's 24/7 operation with almost no downtime. Its whole body dynamic balance system lets it tilt up to around 170 degrees without falling over, carry payloads in the 15 kilograms range, and weave through crowded factory floors with a gait that looks surprisingly natural. It's not shuffling like an old-school bot. It moves like a careful human worker navigating between shelves, machines, and people. Fine motor grippers in the hands let it handle delicate objects, not just heavy boxes. And under the hood, Walker S2 runs on powerful AI chips that fuse vision, touch, and sensor feedback in real time. That means it's not just replaying pre-programmed motions. It's responding to the environment moment by moment. If you love staying ahead of the AI and robotics curve, hit subscribe. I drop these deep dives every day. So what does this all add up to? On one side, you have Fourier's GR2 standing in the middle of a live intersection, proving that humanoids can handle messy, unstructured human environments. On another side, Skywolf is taking military-grade mobility and repackaging it as a flexible tool for rescue, security, and industrial work. And behind the scenes, UB Tech's Walker S2 army is quietly rolling off production lines, ready to replace or augment human labor in factories across China. So what do you think? Are robot traffic cops, robot wolves, and humanoid factory workers the future you expected? Or is this all moving a little too fast? Share your thoughts in the comments. And if you think robot traffic cops and robotic wolves are wild, wait until you see what Xpeng dropped. Their new humanoid moves so realistically that people can't decide if it's impressive or disturbing. In the latest showcase, two female iron robots walk side by side down a straight line. Their movements sync up so perfectly that your brain wants to believe you're looking at a mirror reflection. But here's the crazy part. They're both real robots moving in real time. There's no mirror at all. The coordination is insane because it proves these machines can mimic the same motion patterns with absolute precision. When you see them moving together like that, it just hits different. Now let's talk about why this walk feels so disturbingly human. Xpeng took inspiration from fashion models strutting down a catwalk. The robots place their feet in a perfect straight line. Their hips sway naturally. Their arms swing with every step. There's no clunky robot stiffness anywhere. This is where it gets mind-blowing. Xpeng built iron with a fake spine and muscle system that actually copies how human bodies work. Iron uses something called rapid imitation learning, which means the robot can watch and copy human movements in just seconds. The result? A walk so smooth that experts are calling it surprisingly lifelike. And that smoothness isn't just for show. It's the doorway to understanding what's happening inside this machine. Once you see irons move like that, you naturally wonder what kind of engineering makes it possible. Here's where things get even more interesting. Because once you understand the basics, you start to see the real engineering magic happening underneath. What really sets iron apart is the way Xpeng built irons from the inside. Instead of using stiff metal parts like older robots, iron has a flexible, human-like spine that bends and moves naturally. This lets irons shift iron's weight smoothly, absorb small impacts, and stay balanced the same way a real person does when walking or turning. Iron also has synthetic muscles, soft, stretchy actuators that work a lot like real muscle fibers. These muscles don't just pull iron's joints, they spread force across iron's whole body. That's why iron's hips sway, iron's shoulders loosen, and iron's torso moves with smooth, natural motion instead of sharp robot movements. When iron walks like a person made of metal and software, moving in a way that feels almost alive. And that lifelike motion doesn't just look impressive, it leads directly into the bigger picture of why iron matters. When a robot moves this convincingly, it changes everything. People might actually want to interact with these machines in offices, stores, or museums. You're not dealing with that old, jerky robotics demo anymore. This is controlled, deliberate, catwalk-level precision. And that raises the bar for every other company in this space. Xpeng just showed us what's possible when you nail the hardware, tune the control algorithms perfectly, and integrate real-time adaptation. Before we move on, if you love deep-dive robot breakdowns like this, subscribe to the NextGen AI so you don't miss the next big AI moment. When Iron walked onto the stage at Xpeng's big event in Guangzhou, China, the company showed Iron's movement in a simple, controlled way. The team focused on Iron's balance, stability, and how smoothly Iron moved under real stage lighting. To make the demo clearer, Xpeng did something unusual. The engineers carefully removed a few pieces of Iron's outer skin right there on stage. This wasn't for drama. It was to show the audience what was actually inside. Under the surface were robotic joints, metal parts, and all the systems working together to create Iron's smooth movement. The surprising part, even with some of the outside removed, Iron kept walking normally. This proved that the movement wasn't a trick, it was real engineering. So what makes Iron look so lifelike? Iron is about 5 feet 8 inches tall, similar to a real person. But the real difference is in the way Iron moves. Iron has 82 degrees of freedom across the body. Each hand has 22 moving points. This allows Iron to bend, turn, point, and grab things in a very natural way. Iron is powered by Xpeng's VLT brain, vision, language, and task. This system works with 2 more AI models, VLA, which helps Iron see and act, and VLM, which helps Iron understand what Iron is looking at. All of this runs on 3 custom chips that together deliver 2,250 TOPS of computing power. Xpeng also chose to give Iron a female appearance for a reason. They want the robot to feel warm, gentle, and friendly for future home use. Buyers will even be able to pick different body types and styles. The CEO compared it to choosing a car color. In the future, people might choose their robots look the same way. What do you think? Is Iron impressive or a little too human for comfort? Let me know below. Let me tell you about Xpeng real quick, because it helps explain why Iron exists in the first place. Xpeng is one of China's biggest electric car companies, often called the Chinese Tesla. They've built smart, high-tech cars for years. But here's something interesting. Out of the 7 robot versions Xpeng created, 5 were 4-legged robots like robot dogs. They eventually stopped making those because human-shaped robots collect much better data in human spaces like homes, stores, and offices. Iron also comes with some strong hardware. Xpeng says Iron has the first all-solid-state battery ever used in a robot. These batteries are safer, last longer, and hold more energy. Iron also uses shape-changing fake muscles and soft skin with touch sensors to make interactions feel more natural. But even with all this advanced tech, Xpeng is careful about how they deploy Iron. They plan to start preparing for mass production this year and hope to begin full production by late 2026. Still, they're avoiding factory jobs because Iron's hands wear out too fast. And they aren't ready to use Iron for home chores yet because homes are unpredictable and safety is a big concern. But while Xpeng is shocking the world with near-perfect human motion, another country tried to do the same, and things went hilariously wrong. Let's talk about Russia's AI-idol robot. While America pushes out humanoids that move with military precision, and China keeps dropping robots that glide over rocky hills like they're floating, Russia stepped onto the stage with a robot that looked almost too human, and then immediately face-planted in front of everyone. This is the story of Adol, a humanoid designed to make Russia a serious player in robotics, a robot with a rare human-like face and a surprisingly realistic body, yet one that couldn't walk 10 steps without looking like it had just stumbled out of a nightclub. The big reveal happened in Moscow on November 10, 2025. At first glance, people were quietly impressed. Unlike Tesla's blank-faced Optimus, Adol actually looked human. It had a fully sculpted face with skin-like features capable of emotional shades, subtle smiles, soft micro-expressions that made you pause and think, wait, is that a real person under there? Even the body proportions were surprisingly natural, and this is extremely rare. Most companies don't try to combine a realistic face with a functional full-body system. It's too hard, too uncanny, too easy to creep people out. But Adol Robotics went all in, hoping to create a robot that could eventually interact with people the way a human would. Then Adol took its first steps, and everything unraveled instantly. At first it looked normal, if a little stiff, but within 2 seconds you could see something was off. The knees trembled, the torso leaned forward unnaturally, the gait became uneven, almost like its internal balancing system was arguing with itself. And then, to the horror and amusement of everyone watching, Adol tipped forward in slow motion, lost all balance, and slammed face first into the stage. The audience froze, and some, well, they couldn't hold the laugh in. Russia had tried to show the world its big robotics moment, but instead delivered one of the funniest tech fails of the year. Before we go further, make sure to subscribe to NextGen AI, your one-stop place for daily humanoid breakthroughs. Here's the irony. Adol is actually a serious piece of engineering. Built by Adol Robotics, a Moscow startup focused on reducing dependency on foreign components, it's made of 77% domestically sourced parts, an impressive number considering sanctions have cut access to advanced chips and sensors. The robot stands about 5 feet 4, packs over 40 degrees of freedom, and runs onboard neural networks that merge camera vision, audio, and touch feedback into something the engineers proudly call harmonic reasoning. In simple terms, the robot is designed to adapt in real time, to adjust its movements with each step like a foundation model adjusting to new data. The face isn't just decoration either. It can produce 12 core expressions, from joy to frustration to calm neutrality, plus hundreds of tiny micro-reactions. On paper, Adol should have walked out like a futuristic actor and won applause. But robotics is not kind to confidence. Do you think Russia can fix this robot, or is it already too late? Let us know in the comments. I always check what you guys say. The biggest issue was the walking. Humanoid locomotion is notoriously brutal. Tesla spent years getting Optimus to stop wobbling. Even Boston Dynamics took decades to achieve the smooth motion we see today. Adol simply wasn't ready. CEO Vitukin later explained that the bright stage lights interfered with the depth sensors, throwing off the calibration and confusing the robot's perception of the floor. One wrong reading in a bipedal system is enough to trigger a collapse. Humans fall all the time. Robots fall harder. And unfortunately for Russia, they fell during the one moment they needed everything to go perfectly. Of course, the internet didn't care about engineering explanations. The failure spread instantly. People joked that the robot walked like a classic drunk Russian, which, yes, is a stereotype. But the wobbling was so exaggerated that it practically invited commentary. The knees buckled like someone balancing after 6 vodka shots. The sideways lean looked like it was searching for a wall. And once the face hit the ground, the comparison became unavoidable. But behind the jokes, there's a real point worth acknowledging. That shaky, unbalanced walk shows exactly how early this robot is. The leg control algorithms need major refinement. The balancing model needs more data. The real-world calibration is nowhere near stable enough. The robot wasn't drunk. The software was. When you put Adol next to what America is building, the differences become clear fast. Tesla Optimus Gen 3 moves with industrial precision. Figure 03 has one of the most natural gaits in the world. Its posture and motion look eerily fluid. Russia flipped that philosophy entirely. Adel prioritizes human likeness over mechanical perfection. In a way, it feels like a character from a sci-fi film that escaped before the animation was finished. It's bold, it's weird, and it's definitely risky, because people judge robots by their movement before anything else. A beautiful face won't save a robot if the legs give out. But here's the part the internet didn't see. After the fall, Idle wasn't done. Engineers rushed backstage, adjusted the calibration, and restarted its systems. When the robot returned to the stage for a second attempt, it stood upright, lifted its arm, and waved without collapsing. Not perfect, but stable. Some attendees said the robot even moved smoothly backstage, picking up props and interacting with objects like a normal humanoid prototype should. But that footage never went viral. Only the fall did. This is the curse of public robotics demos. When it works, nobody notices. When it fails, it becomes a global punchline. And while Russia struggles to get one robot to walk straight, Tesla is already deploying an entire fleet. Because Optimus Gen 3 just changed the whole game. Elon Musk just revealed Optimus Gen 3 at Tesla's 2025 shareholder meeting, confirming its major upgrades and the official reveal date. This new version isn't just improved, it's a complete redesign built for real-world autonomy. Inside Tesla's production floor, Gen 3 robots are already walking, working, and charging themselves with zero human control. The future Musk promised is no longer coming. It's already here. Tesla's Optimus just got some major upgrades, and today, we're breaking them down one by one. First off, inside Tesla's production floor, Gen 3 robots are roaming freely, fully autonomous. No cables, no joystick control, no human supervision. They navigate hallways, lift components, and when their battery dips, they casually walk themselves over to a charging dock like it's the most natural thing in the world. It's the kind of scene you'd expect in a sci-fi movie, except it's not CGI. It's real footage coming from Tesla's Fremont facility in 2025. Now, what makes this version such a big deal? Because Gen 3 is the first true leap, not a step, in humanoid design. Everything about it, from the way it moves to the way it thinks, has been rebuilt from the ground up. The frame is lighter, the actuators are more compact, and the balance control is eerily human. Watch it walk, and you'll notice it no longer looks robotic or clunky. Every joint flexes smoothly. Each footstep has micro-adjustments. Every motion has natural weight. Let's rewind for context. The first Optimus prototype back in 2022 was impressive for what it was, a mechanical skeleton showing proof of concept. Then Gen 2 brought controlled movements and basic manipulation. But Gen 3? It's different. This is Tesla's first humanoid that behaves like a living system. Its 50+ degrees of freedom allow human-level fluidity. The redesigned actuators use Tesla's new electromechanical architecture that delivers higher torque with less power draw, meaning smoother motion and longer operation on a single charge. The spine, knees, and hips have been tuned for balance that reacts dynamically. It can now recover from slips or bumps without falling. But the real magic lies in the hands. Tesla engineers call them the most difficult mechanical challenge we've ever faced. Each hand now has articulated fingers with high-precision sensors that detect force, texture, and angle in real time. You've probably seen the viral clip, Optimus carefully picking up an egg and rotating it between its fingertips without cracking the shell. That wasn't staged. It was a live demo. Optimus Gen 3 is now capable of manipulating everyday objects that most robots can't even identify. Folding laundry, stacking items, wiping surfaces, picking up trash, sorting materials, all done autonomously. Tesla's AI team trained these behaviors using the same vision-based neural networks that power autopilot. Would you actually want an Optimus robot in your home? Be honest, helpful assistant or creepy roommate. That means Optimus doesn't rely on pre-programmed paths. It perceives the world around it through cameras, builds a 3D map of its environment, and makes decisions on the fly. It's not reacting, it's reasoning. It understands the difference between a tool and a dish, between something fragile and something heavy. It can generalize actions. If it learns how to pick up one towel, it can handle any towel. That level of generalization is exactly what separates a toy robot from a real worker. Inside Tesla facilities, these robots are now assisting with part handling, simple logistics, and cleaning tasks. They move around staff, detect obstacles, and even mirror human motion for learning tasks. And when they're done, they plug themselves in, literally walking over to their dock and recharging. No human involvement. What's wild is that Gen 3's brain runs on Tesla's unified AI platform, the same system training millions of self-driving cars every day. Every Optimus unit collects data, improves through reinforcement learning, and sends that knowledge back to Tesla's neural network. Essentially, the entire robot fleet learns together. The more they move, the smarter they all get. That's the Tesla effect. Just like autopilot went from 0 to city driving capable in a few years, Optimus is evolving through iteration speed no other robotics company can match. Each update improves walking, dexterity, and problem solving, almost like over-the-air software updates for a human body. Gen 3 also got a full aesthetic redesign. The outer shell is smoother, more organic, and made from lightweight composite materials to reduce weight and improve energy efficiency. The proportions are closer to a fit adult human, around 5 feet 8 inches, 55 kilograms, and capable of carrying 20 kilograms comfortably. The motion control system now allows dynamic balancing, so you can push it slightly, and it recenters itself just like a person would. The cameras, placed in the head and torso, have ultra-wide field vision with depth perception. Combine that with Tesla's neural net inference chip, and you get real-time scene understanding at millisecond latency. It doesn't just see the world, it interprets it. If you're excited about where Tesla and humanoid robots are heading, make sure to hit that subscribe button. We cover every major AI and robotics breakthrough right here on NextGen AI. Now here's where things go from exciting to absolutely insane. Tesla is not just building robots, it's industrializing them. The company already has a pilot line in Fremont producing early Gen 3 units, and the ramp plan looks almost impossible. Phase 1, 1 million units per year from Fremont. Phase 2, 10 million units annually from Giga Texas. And long-term, Tesla's global target is hundreds of millions of Optimus units. Let that sink in. Hundreds of millions of humanoids potentially in circulation before 2035. For comparison, humanity produced about 1.5 billion cars in the last century. Tesla wants to surpass that within a few decades with robots. And they're treating this exactly like a car business. Optimus shares over 70% of its supply chain components with Tesla's vehicle ecosystem: sensors, batteries, actuators, chips, meaning the scaling potential is enormous. When Musk said, "This will be the fastest manufacturing ramp of any complex product ever built," he wasn't exaggerating. The economic implications are beyond massive. Each Optimus Gen 3 unit costs roughly $20,000 at scale, the same ballpark as a Toyota Corolla. For that price, you're getting a worker that never sleeps, never gets sick, and never asks for a paycheck. Imagine what that does to global production. Factories could operate 24/7 without overtime. Construction costs could drop by 80 to 90%. Farming, logistics, mining, all could be automated with near-zero human labor. Tesla's term for this vision is sustainable abundance. The idea is simple but radical. When physical work becomes infinitely available and infinitely cheap, the cost of goods collapses. Housing, food, energy, everything could drop to near-zero marginal cost. It's the first step toward an economy where basic needs aren't constrained by human labor. Now, this is where things get emotional. Tesla's collaboration with Neuralink could make Gen 3 not just an autonomous worker, but a full-body extension for humans. We've already seen Neuralink allow a paralyzed person to control a computer cursor with thought alone. The next milestone is giving someone full-body motion using an Optimus frame. Imagine a person who's been unable to walk for years suddenly standing, running, or dancing again, not in virtual reality, but in the real world, through a robotic body they control with their brain. The feedback system would even transmit sensation, texture, pressure, maybe even warmth. For people with severe disabilities, that's not science fiction. It's hope. But the same tech raises profound questions. What happens when a human consciousness can effectively live through a robot body? Where does the boundary between mind and machine end? Tesla calls it symbiosis. Critics call it digital reincarnation. Either way, it's coming faster than anyone expected. Of course, it's not all smooth sailing. The biggest engineering obstacle remains the hand. Recreating the precision and control of 27 bones and 34 muscles in a lightweight electromechanical system is brutally hard. Each movement requires micro-level torque control, instant feedback, and fine motor algorithms that can adjust in milliseconds. Then there's perception. Real-world environments are chaotic, reflections, fabric folds, lighting shifts, unpredictable human movement. Training an AI that can adapt safely in that chaos is an enormous challenge. Tesla's solution is to feed the robots massive amounts of real-world data through simulated environments powered by the Dojo supercomputer. But even then, the gap between lab and life is tricky. Manufacturing at scale is another mountain. No one's ever built millions of humanoid robots before. The actuator supply chain, high-density batteries, heat management systems, all need to be designed from scratch. Tesla is essentially inventing a new industry in real time. Here's what's next. The version Tesla showed at the 2025 shareholder meeting is Optimus 2.5, the final prototype before Gen 3 goes into full production in 2026. After that, Tesla plans annual upgrades, Gen 4 in 2027, Gen 5 in 2028, and so on. Each one lighter, smarter, faster, and more efficient. That pace mirrors the smartphone industry. Just like we went from flip phones to facial recognition in a decade, humanoids will go from factory assistants to fully capable personal helpers by 2030. The robot in your living room will evolve faster than any consumer technology in history. Here's the kicker. This isn't just a passion project. It's tied directly to Tesla's long-term business incentives. The company's CEO Performance Award for 2025 includes milestones like deploying 1 million Optimus units by 2035. If Tesla hits them, Musk's payout could exceed $1 trillion. Over 75% of shareholders already approved it. That means every executive, every engineer, every dollar in R&D is aligned toward mass-producing humanoids. This isn't hype, it's strategy. Tesla is betting its entire future on automation, betting that Optimus will one day generate more revenue than all their vehicles combined. And with a projected price of $20,000 per unit and demand from both households and industries, that's not unrealistic. Think about where this goes. Factories with no lights because robots don't need them. Construction sites running 24/7. Hospitals using humanoids as physical assistants. Families owning personal robots that cook, clean, and lift heavy objects. Within a decade, these machines could be as common as washing machines. Do you think Tesla's humanoid robots will really replace human workers? Or will they just create new kinds of jobs? I'm curious where you stand on this. But while Tesla pushes humanoids toward mass production and global scale, another revolution is happening quietly. Robots that aren't just functional, but shockingly human. Let's look at the ones redefining realism itself. You think you've seen lifelike robots until one looks at you. Xpeng, a robot that doesn't just move like a human, but embodies the grace of Chinese culture itself. Then there's Mecha, the uncanny valley champion whose expressions are so precise, even psychologists struggle to tell them apart from ours. Number 1 Mecha, the uncanny valley champion. Let's start with the robot that's been breaking the internet and haunting dreams in equal measure. Mecha, created by Engineered Arts in the UK. This isn't just a robot, it's a masterclass in biomimetic engineering. Here's what makes Mecha absolutely revolutionary. This robot features the most advanced facial articulation system ever created. We're talking about dozens of individual actuators working in perfect harmony to produce micro-expressions that even trained psychologists would struggle to distinguish from human reactions. When Mecha raises an eyebrow in skepticism or shows surprise, it's not following a pre-programmed script. It's responding dynamically to conversational context. The tech breakdown gets even wilder. Mecha runs on Engineered Arts' proprietary Tritium operating system, which processes sensory input in real time and generates appropriate emotional responses. The robot's cameras don't just see you, they analyze your facial expressions, body language, and even your tone of voice to calibrate its responses. It's like having a conversation with someone who's reading your soul through algorithms. But here's the kicker. A mecha is deliberately genderless and features gray skin to position itself as a platform rather than a replacement for human interaction. The creators understood something crucial. Making robots too realistic might trigger our natural discomfort with the uncanny valley, but a mecha walks that tightrope perfectly. Number 2, Lifelike, China's cultural ambassador. Now let's jet over to China, where X-Robots has unleashed something extraordinary. Lifelike 2.0, and this beauty is bringing cultural heritage into the robotic age. While Western robots often pursue neutral aesthetics, Xian celebrates traditional Chinese beauty with stunning authenticity. What makes Lifelike 2.0 a game-changer? First, the realism is insane. We're talking about silicone skin that mimics human texture and flexibility, complete with subtle movements that replicate breathing patterns. This robot doesn't just stand there. It exists in space with the same subtle aliveness that humans possess. The facial expressions are powered by over 30 micromotors that create everything from gentle smiles to contemplative gazes. But the real innovation lies in its AI capabilities. Xian 2.0 integrates advanced language models that allow it to engage in culturally nuanced conversations, discuss traditional Chinese arts, and even perform classic poetry recitations with appropriate emotional inflection. This isn't just translation, it's cultural interpretation at the highest level. The application potential is enormous. Museums are already exploring Xian as an interactive guide. Cultural centers are considering it for language education. We're witnessing the birth of robots as cultural ambassadors, preserving and sharing heritage in ways previously impossible. If you had to live with one of these robots, which one would you pick? A mecha or Xian 2.0? Drop your answer below. Number 3, Sophia, the veteran visionary. You can't talk about realistic robots without mentioning the OG celebrity robot, Sophia by Hanson Robotics. Created back in 2016, Sophia has evolved dramatically by 2025, becoming more sophisticated with each software update and hardware refinement. What keeps Sophia relevant in 2025? Continuous evolution. While newer robots might have flashier debuts, Sophia benefits from nearly a decade of real-world interaction data. The AI powering Sophia has processed millions of conversations, learning nuances that can't be programmed, only experienced. Sophia's latest iteration features enhanced emotional intelligence algorithms that can detect sarcasm, humor, and cultural context with impressive accuracy. The robot has become a fixture at AI conferences, giving speeches that blend technical information with philosophical reflection. Sophia even holds citizenship in Saudi Arabia, a controversial but fascinating development that raises profound questions about personhood and rights in the age of AI. The legacy impact? Sophia proved that humanoid robots could capture public imagination and spark meaningful conversations about our technological future. Every realistic robot today stands on Sophia's titanium shoulders. If you're enjoying this deep dive into future tech, hit that subscribe button. More mind-bending AI stories are coming your way. Number 4, Annie from Aniwit, the accessibility pioneer. Here's where things get incredibly meaningful. Annie, developed by Aniwit Robotics, represents a different approach entirely. While other robots focus on realism for entertainment or research, Annie is laser-focused on one mission: transforming life for people with disabilities. The innovation here is profound. Annie combines realistic appearance with functional assistance, creating a companion that doesn't feel like medical equipment. For individuals with mobility challenges, cognitive disabilities, or social anxiety, Annie provides support that's both effective and dignified. The robot can assist with daily tasks, provide medication reminders, facilitate video calls with family, and offer emotional support through genuinely empathetic interactions. What makes Annie special is the thoughtful design philosophy. Instead of trying to be perfectly human, Annie occupies a sweet spot, human enough to connect with emotionally, but distinct enough to avoid confusion. The team at Aniwit consulted extensively with disability advocates, ensuring the technology serves genuine needs rather than pursuing innovation for its own sake. Real-world deployment is already showing transformative results. Elderly individuals living alone report reduced isolation. People with autism spectrum disorders find Annie's consistent, patient communication style incredibly helpful. This is robotics with purpose, and it's beautiful to witness. Do you think humanoid robots should look this realistic, or is it crossing the line? Let me know your thoughts in the comments. Number 5. AZI, the artistic soul. Now things get wonderfully weird with AZI, created by the avant-garde robotics collective automata. This isn't your typical commercial robot. AZI exists at the intersection of technology and art, challenging our perceptions of creativity and consciousness. AZI's design is deliberately thought-provoking. The robot features transparent elements revealing internal mechanisms, creating an aesthetic that celebrates the merger of organic and synthetic. But the real magic happens when AZI creates. This robot doesn't just follow artistic algorithms. It develops a generative style influenced by observing human artists, analyzing art history, and even processing its own experiences in gallery spaces. Critics argue about whether AZI's paintings are truly creative or merely sophisticated mimicry. But isn't that the point? AZI forces us to confront uncomfortable questions. What is creativity? Can machines possess it? Does origin matter if the result moves us emotionally? Gallery installations featuring AZI have become cultural phenomena, with the robot creating live paintings while discussing art philosophy with visitors. Whether you see AZI as artist or tool, there's no denying the profound impact on contemporary discourse about consciousness and creativity. Number 6. X-Robot, the industrial evolution. Let's shift gears to practical application with X-Robot, developed by a consortium of manufacturers tackling real industrial challenges. While other robots on this list prioritize human interaction, X-Robot brings realistic humanoid design to manufacturing environments, and the results are transformative. Why make industrial robots look human? Simple. Existing infrastructure was built for human workers. Rather than redesigning entire factories, X-Robot adapts to use existing tools, workstations, and equipment. The realistic hands can grip standard tools with precision. The human proportion body navigates spaces designed for human workers. The visual systems process information similarly to human sight. But here's what gets exciting. X-Robot can work alongside human employees seamlessly. The realistic appearance triggers natural collaborative instincts rather than the wariness workers might feel around obviously mechanical systems. Teams report actually enjoying working with X-Robots, appreciating their tireless consistency while maintaining human oversight for complex decisions. The economic implications are massive. Instead of expensive retrofitting, companies can integrate X-Robots into existing workflows. We're talking about a manufacturing revolution that's accessible to businesses of all sizes. Number 7. Desdemona, the rock star robot. Finally, let's end with pure spectacle. Desdemona, the world's first robot rock star, created by Engineered Arts in collaboration with the band Jam Galaxy. Yes, you read that right. This robot performs on stage with human musicians, and the results are legitimately mind-blowing. Desdemona isn't just moving to music, she's feeling it. Advanced audio processing algorithms analyze rhythm, melody, and emotional content in real time, generating appropriate physical responses. The robot's expressive face conveys everything from aggressive energy to melancholic introspection, matching the musical mood with uncanny accuracy. The performances raise fascinating questions about art and authenticity. Audiences report genuine emotional connection with Desdemona's performances. When she sings, synthesized vocals processed through emotion modeling AI, people respond viscerally. Is this emotional manipulation or a new form of authentic expression? Beyond entertainment, Desdemona represents something profound. Robots participating in uniquely human activities not as imitators, but as collaborators bringing novel perspectives to creative endeavors. So there you have it. 7 remarkable robots pushing the boundaries of what's possible in 2025. From Emeka's uncanny expressiveness to Desdemona's stage presence, from Annie's compassionate assistance to Zrobot's industrial revolution, we're witnessing a transformation in how humans and machines coexist. The question is, how will we shape this relationship? Will we embrace these technological marvels as partners in building a better future, or will fear hold us back? One thing's certain, the future is here, it's sophisticated, and it's absolutely fascinating. Welcome to the age of realistic robotics. The revolution will be humanized,